Welcome to New Way Air Bearings. I'm Drew Devitt, and in this video I'd like to discuss with you restriction and compensation, which are the defining characteristics of air bearings and separate them from all other pneumatic systems. So having a look at the computer screen here, we've got a side view of a normal flat air bearing. In this case it's an orifice air bearing, and we're talking about two basic restrictions. We've got an input of say 4 bar, and then there's a restrictor that shuts the flow down, and then there's a restriction of the gap itself. So as the air flows through the gap, that restriction is what is actually carrying the load. So the pressure in the gap times the area has to equal the load that's being put on it. Now the restrictor is normally designed so that if you've got a 4 bar input, you get about 2 bar in the gap. Now that's as a rough estimate starting point. As you increase the pressure to the bearing, the gap will get smaller, and relatively less flow through the orifice creates a higher pressure in the gap. And we can see that when we go to the New Way air bearing website. These are lift load curves. Across the bottom you see the gap in microns from 0 to 25. And across or up and down the axis, we've got the load here in newtons and here in pounds. So as the pressure or load on the bearing increases, the gap gets smaller, and obviously the pressure in the gap actually goes up. This is the idea of compensation. It's what gives air bearings a relatively high degree of stiffness. If we go back to the presentation. So what we're going to talk about are a little more complicated system than just a flat bearing. Here's a New Way air bushing, but in the illustration here we've got an orifice type air bearing with plumbing to supply the orifices. So now looking at side views, if you've got one source and a common plumbing system without any restriction in it, there's no reason for this shaft to actually center itself. All the air is going to take the path of least resistance. The flow through a gap is a squared function of the gap, so there's actually less restriction when you have all the air coming out one side, and this shaft is not going to center itself. If you had 4 separate pumps, then you would have a compensating effect, because as you put a load on the shaft, this gap would get smaller and the pressure would go up. If you put an annular groove, which is not uncommon, here's an example of an annular groove inside of a bushing. Again, all the air pressure then is going to find its way along the groove and come up the top. So whether you connect these things on the ID or whether you connect them on the OD, you're going to have the same effect without some kind of restriction. Now, in hydrostatic systems using oil or water, sometimes you'll see pockets used. The advantage there is you can get the exact same pressure across the whole pocket. The problem with air is that it's compressible, so when you have thick layers of it, it loses stiffness and it becomes subject to pneumatic hammer. But with oil and water, you can actually increase the amount of average pressure in the gap. Again, if you've got pockets, which is basically trying to separate this annular groove, unless you've got restriction somewhere else, you're still going to be defeated because all the air is just going to come out the one bigger gap. Now by adding a restrictor, an orifice or a capillary or some type of device that's going to restrict the flow so that you've got say 4 bar supply and 2 bar in the gap, then as the bearing gets displaced from load, the gap gets smaller, the pressure goes up, the gap up here gets bigger, and the pressure drops. So you have this wonderful balancing effect that's referred to as compensation. Now when you have a load on the shaft that's not pointed directly at an orifice, you wind up having a hard time trying to get the pressure to actually go to where it needs to be in order to support this load. So what do designers do? They add more orifices. Now this is technically superior, but it's also very expensive to try to compensate a bearing this way. So another way to do it, and it's the way we choose here at New Way, is a porous media restriction. So this damps the flow of air into the gap and gives us millions of evenly distributed orifices all the way around the 360 degrees. And it does the compensation right directly at the gap, which is really the best way to provide compensation.